Patrolling space like a sentry, the satellite telescope SWIFT is on constant lookout for cosmic disasters. And when it finds one, down on Earth, word spreads quickly. Every few days, the satellite spots a violent eruption in deep space, sending dozens of stargazers scrambling. Whether they're seasoned pros or high school amateurs, their goal is the same.
Go to camera focus mode, and then we're going to need to move the dome. Casey?
To catch a glimpse of a star in its final death throes. Going supernova. And leaving in its wake the strangest phenomenon in the cosmos. A black hole.
Nothing survives encounters with black holes. The black hole wins. It wins every time.
When something falls into a black hole, it's essentially gone from our universe.
They rip stuff apart and eat them. And then they burp and they're ready for the next course.
And now, evidence of something even more ominous. A new kind of black hole. Of unfathomable size and power.
That's a big galaxy, and right down at the center, we think there's probably a black hole that's got a mass that approaches 1 billion suns.
Today, scientists are finding black holes are bigger, stronger, and more destructive than they ever imagined.
It creates energy fields that would fry any life in its vicinity.
Not only do they consume everything that comes near,
you stick your finger down in there, you ain't getting it back.
But their power may reach across galaxies and beyond.
Did the universe really have to be made with these things in it?
We'd like to think they're far, far away. But what if, in our own cosmic backyard, there lurks the monster of the Milky Way? Right now on Nova.
Major funding for NOVA is provided by the following.
This is just enormous.
As he pores over a set of x-rays, Brian McNamara struggles to diagnose a complicated ailment.
So that's pretty strange.
But his patient isn't a person or any earthly creature. It's a cluster of galaxies, 2.5 billion light years away, with a giant blast of energy spewing from the center. This is the most powerful explosion in the universe since the Big Bang.
To put this on sort of an Earth scale, it's equivalent to about 1 trillion atomic explosions. So it's an enormous amount of energy.
What could produce such awesome power? Whatever it is, it seems to live at the very core of galaxies. And many believe our own galaxy, the Milky Way, is not immune, harboring a powerful secret at its heart. What could lie at the center of the Milky Way? One of the pioneering explorers of our galaxy is Eric Becklin. He's been trying to unlock the mysteries of the galactic center for more than 40 years. But first, he had to find it.
Back then, people weren't even sure where the center was. There was some vague understanding. There was a radio source called Sagittarius A, a very strong radio source, but there was even debate whether that was really the center or not.
Examining other distant galaxies, astronomers knew that the center is usually the brightest spot, tightly packed with stars. But when they tried to pinpoint the center of our own galaxy, the Milky Way, they ran into a problem. the central stars were shrouded by cosmic dust.
There is so much dust between us and the galactic center, it is completely opaque. You do not see the stars in the galactic center. The most powerful telescopes cannot see it.
But there are other kinds of light that can pass through, like infrared, a form of light and heat invisible to the naked eye that travels in slightly longer waves.
Infrared radiation gets through the dust because its wavelengths are longer and the dust just kind of rides on the infrared wave.
In the 1960s, Becklin belonged to a Caltech team that bought an infrared detector from a military contractor and attached it to the end of a telescope.
It was in August of 1966. I was up at Mount Wilson. It was a beautiful night on a small 24-inch telescope. And as we were looking with the infrared detector, we were seeing more and more stars.
A simple chart recorded the infrared light of stars. Stars that until then had remained hidden behind a veil of dust and debris.
This is a signal in the infrared, and each star gives you more signal. And we were building up, as we were getting closer to the center, more and more stars. We were actually seeing through the dust for the first time, and then came to a peak, and then back down again. And I knew immediately that that was the center of our Milky Way, and that I was the first person to actually see the star in the core of our galaxy.
Located the heart of the Milky Way. From our perspective, an inconspicuous speck near the constellation Sagittarius. As a giant spiraling disk of hundreds of billions of stars, 100,000 light years from end to end. Our sun, about halfway out from the center, sits in the peaceful suburbs. But at the galaxy's core, the neighborhood gets more exciting and dangerous.
There's a lot of gas. There's a lot of dust. This is absolutely the most crowded place in our galaxy.
From Earth, we can see a few thousand stars with the naked eye. If you went to the galactic center, there would be millions of stars filling the sky.
It's the big time. It's where the show really goes on in the galaxy. And so if you go there, you're very much aware of being a tiny little mouse in Times Square, and somebody's liable to step on you.
For years, scientists suspected that a powerful force dominated this galactic Times Square. It had to come from an unimaginably massive object. Some thought it had to be a black hole. An object so strange, it's hard to describe.
What's a black hole? It's a region of space.
It's a point of infinite density. We don't know how to wrap our brains around that. If you fall in, you never come out.
It's not the point of no return, it's the sphere of no return.
Now you throw in a hungry beast in the middle of it all.
It's this monstrous, mysterious thing.
And if you can imagine taking a bowling ball
That, I don't know, eats everything. That's not true.
You have something, you drop it off the top of a building, you're falling in to the deepest well you can possibly imagine. Physicists have just as hard a time as anybody else understanding this sort of thing.
It's a black hole. There's no other phrase we can possibly use to describe it.
The current idea of this bizarre creature comes from a radical view of space, time, and gravity. Welcome to the universe according to Albert Einstein.
Albert Einstein had this crazy idea that space and time were curved, and it was the curvature of space that gave the appearance of gravity.
We tend to think of space as rigid and stable, but Einstein proposed that space and time are woven together in a flexible fabric. Massive objects like the Sun actually bend and warp the fabric of space-time, creating troughs that smaller objects can fall into.
What actually happens is matter warps space-time. So the very space, the three-dimensional space that we walk through, warps slightly. Every warps in on me ever so slightly, but because we're not very massive, it's so minuscule that we don't sense it.
If an object is massive enough, like the Earth, it will warp space-time so we can sense it and fall towards it. That's gravity. But what happens if an object is much, much more massive than the Earth or the Sun? In theory, it could warp the fabric so much it would create an actual hole in space-time. Once something fell in, it couldn't escape, not even light itself.
So imagine a place where the gravity is so strong, turning on a flashlight. The light would go up and it would never leave. It would curve and come back down just the way a tossed ball on Earth is not traveling fast enough. It goes up, curves, and comes back down.
Space itself is falling inside the black hole. It's rather like a river falling over a waterfall. It's like that, except it's space itself that's falling over the cliff. There's a place where the space starts moving faster than light. So the light, which is trying to get out, it's rather like a kayaker trying to make their way upstream on a river that's going too fast. They get dragged down to the center of the black hole.
Gravity becomes a riptide. The closer you get, the stronger the current. Eventually, you reach the event horizon, the point of no return. Deep inside, whatever goes in is lost in a point of infinite density.
The matter goes inside the surface of the black hole, shrinks down to the very center, where it gets destroyed in a region of infinite warped space and time, and it's gone.
And so, it seems, are the laws of physics. At the center of a black hole, all equations break down. Even for physicists, what happens deep inside a black hole is a mystery.
Every time.
When something falls into a black hole, it's essentially gone from our universe.
They rip stuff apart and eat them. And then they burp and they're ready for the next course.
And now, evidence of something even more ominous. A new kind of black hole, of unfathomable size and power. Every few days, the satellite spots a violent eruption in deep space, sending dozens of stargazers scrambling. Whether they're seasoned pros or high school amateurs, their goal is the same.
Go to camera focus mode, then we're going to need to move the dome. Casey?
To catch a glimpse of a star in its final death throes. Going supernova. And leaving in its wake the strangest phenomenon in the cosmos. A black hole.
Nothing survives encounters with black holes. The black hole wins. It wins every.
Patrolling space like a sentry, the satellite telescope SWIFT is on constant lookout for cosmic disasters. And when it finds one, down on Earth, word spreads quickly.